I'd like to share a little bit about the key differences between a rigid printed circuit board and a flexible printed circuit board. Obviously, this is a typical printed circuit board, and these are fabricated using very high, stable, high temperature resistance materials such as glass-filled epoxy that give dimensional stability and flatness and rigidity through a process. And flexible circuits are fabricated out of high-performance plastic films that have been engineered to withstand the temperatures needed for populating and running through a surface mount or a heated oven for solder reflow. The printed circuit boards, the rigid kind, everything that you want to mount on the circuit board can be mounted on a flexible circuit board. When you're selecting components, there is not a difference between, well, this particular integrated chip I can only mount on a rigid board. That is not the true statement. You can mount it on either. There's no design factor there. Surface mount, leaded devices, it's the same for both. One of the things that is a factor in printed circuit board, the flexible version, is XY dimensional stability. So in a rigid board, you get very precise material stability in the XY plane, but in flex circuits, they can expand or contract up to a thousandth of an inch per inch. So over a 12-inch long flexible circuit, you could have it grow 12 thousandths of an inch. And that usually isn't a problem, but it is a factor for the manufacturers of the flex circuits to make sure we're anticipating that shrink or that expansion of that pattern. The primary difference, though, for flex circuits, as you might expect, is that we can integrate flexible tails and into the circuit board and eliminating the connector and the additional component of a tail or a ribbon cable. And obviously this is rigid. For flex circuits, you can rigidize and provide stability under components, or if you were mechanically mounting it into a housing, it can have a rigidity factor behind the flex circuit as well. Flexible circuits can also have the nomenclature put on the front surface, just like the nomenclature for a printed circuit board. Do take note that often the cost of adding nomenclature is on top of the base price, so don't automatically assume that you get nomenclature automatically. It would be something you would bring up during the quote process. One of the key things you want to understand as a design engineer, however, is that while a circuit board, a rigid circuit board, is somewhat of a commodity, and as you're modeling your assembly, you don't have to get very definitive about the circuit board itself. Flex circuits, on the other hand, really become part of the package design early on, and so you don't just overlook it. You have to understand how it's going to be packaged, how these are going to be plugged into different connectors, and you would often do a paper doll type of situation. So a flex circuit, although it provides really nice packaging improvement and density improvements, that design of that circuit board is done further up in the product life cycle as you're laying out the board. The surface types of finishes that are on the boards can be the same as well. So we can have gold plating, we can have organic coating, solder surfaces that are needed as well for flex circuits. So in general, you can look at both types of circuit boards as being almost equivalent. Each have their unique properties that you need to take into account.